Hey guys, I'm going to start recording a few little things for our class, some lessons on how to do some things. So to do that, we'll be going through the class notebook, which you can access through here, and you can also save it to your desktop, which is what I've done. So it's easy to use. Once you get here, in your content library, and then first unit is linear graphs. Okay, and then we're going to have lesson by lesson here on your OneNote. So up here in the top right corner, into full screen mode, and just be able to scroll through this. Okay, so I'm going to annotate this so you'll have my notes, and we'll go from there. So um, today's learning goal is to know how to determine the gradient of a line from its equation and use it and a point to sketch its graph. Okay, so first thing we need to be able to do is understand what gradient is. Now that's a stupid pen, so I'm going to change it. Identify gradient and y-intercept from its equation. Okay, we're also going to rearrange equations, okay, because we need this y equals mx plus c form, and we're going to actually sketch at the end. Okay, so that's our goal for today. Alright, so to start, I would have got you to watch YouTube and Slope Dude. Okay, so you'll do that in your Do Now activity, which will run through Teams, but for now, Slope Dude. The key ideas here are that Slope Dude always moves from left to right, just like reading a book. Okay, so that's the main thing. Okay, so this direction. Okay, I'm going to change pen, blue. Okay, this one here was puff puff positive gradient. Okay, so this line here, always positive. Okay, so remember that. Next one here, negative gradient. Okay, so heading down in this direction, in a straight line, of course, negative gradient. Next part, okay, zero gradient. So this type of equation, it would have the form y equals something, okay, and no x's. Okay, this one here would be y equals positive mx plus c. This one here would be y equals negative mx plus c. Okay, this one would just be y equals 3, y equals minus 2, etc., etc. Okay, there's no x's in those ones. These ones here, the vertical lines, okay, means it's undefined gradient. Okay, so what this means is that it's going to have an equation, x equals something. So that could be x equals 4, x equals 2. Okay, so that's the key messages from Slope Dude. Okay, so you've got positive, negative, zero gradient, and undefined gradient. Okay. All right. So first thing is our gradient. Okay, and we would have seen this important thing here: rise over run. Okay, so what that means is we have a straight line. Okay, going up in this direction. This is our rise. This is our run. Okay, so from this point here to this point here is our run. That's our x values. This point here is our, and this one here is y2 minus y1. Okay, so we can have our rise over run as m equals y2 minus y1 over x2 minus x1. Okay. Now, gradient, okay, that's the formula for it, but what gradient actually is the change in y per 1 unit change in x, or, okay, the rate of change of y with respect to x, okay? This part is Very important, okay? So the gradient tells us the rate of change of y with respect to x. So here we're looking at y equals mx plus c. Okay, so m is the gradient and c tells us the y-intercept. Now with the c bit, it's the whole thing including the sign. Okay, so the sign out the front, positive or negative. Okay, so what we want to do in this particular example is find the gradient and y-intercept for these linear relations. Okay, so first off, we're going to start with c and m. We're going to start with the y-intercept. Okay, so in this case, c is simply minus 3. So the y-intercept is 0, x0 minus 3. Okay. Now, the gradient bit, okay, is, I'm just going to change the thickness. Alright. Okay, is this plus 5 bit. Okay, so this one here has a gradient of 5, which actually means 5 over 1. Okay, so referring back to our rise over run, okay, what this means is it has a rise of 5 and a run of 1, okay, moving left to right just like slope did. So therefore, the shape of the line is going to head in this general direction, okay, 5 and 1 across. Okay. Now, for our next graph, okay, plus 2, so c equals 2. Okay. Now here's an interesting one. We've got a minus out the front of the x. Okay, I'm just going to take this one down here. So this means that m equals minus 1. Okay, because remember in algebra we don't use the number 1 because any variable times by 1 is actually just that variable. So we just leave it as minus x in this case. So what that means is it's actually minus 1 over 1. So now this bit here has a rise of minus 1 and a run of 1. Okay, so graphically how that will look is rise minus 1, run, okay, 1. Remember, always left to right. So the graph is going to be shaped in this direction. Now this one here, I'll do this in green pen, okay, running out of room a bit. C equals 6, so the y-intercept is 6. Okay, now this bit here, minus 7 over 2. N equals minus 7 over 2. So rise, minus 7, run 2. Okay, so what that means is we go down 7 and run 2. Okay, so like that. Now that's identifying the gradient and y-intercept from a linear relation. Okay, so now we're going to use that information to sketch the graph. Okay, so I'm going to go back to my black pen. Now I have the function y equals 2x minus 1. Okay, so first thing we do, y-intercept. Okay, here it is here, c equals minus 1. Okay, then we're going to find the gradient. Okay, so remember, forgot, equals mx plus c. Okay, so m in this case is 2, which means 2 over 1, which is 2 up, 1 across. Okay, so it's going to run in this general direction. Okay, so why is the y-intercept so important to us? Okay, well, that tells us our starting position, our initial position. Okay, now then from there we're going to use the gradient so this part here, to determine where we go. So what I can do here is using shapes. Okay. Have my Cartesian plane. Now, of course, we always have to label x, y. Okay. Now, our starting position, as we said before, is c equals -1. So we know that it's going to start down here somewhere. It doesn't matter where we put it on the graph because all we need to do is label that point. And I'm going to label it x is 0, y is -1. Okay, so we can draw a little arrow there to point to that. Then, the next thing we know is it's going to head in this general direction, okay? It's positive gradient. So we know that it's going to cross over here somewhere. So all we need to do now is we have it goes up by 2. So as long as we keep the same 0, 1, 2, okay? So we've gone up 2, 1, 2, and we're going to go across 1. Okay, so this point here, from -1 up to, we have a y value of 1, and our x value has now gone from 0 across by 1, so 1. So that point there is 1, 1. Okay, and our straight line, which is probably, I'm going to try and draw with this thing, okay, is in this general direction. Okay, and that's pretty good. Obviously, you're gonna, okay.